Hello. Good morning. This is a rainy, lazy Saturday, and we are gonna talk all about lazy evaluation. So, lazy evaluation is one of the very popular approach in for compilers that compiles codes. It is a strategy where expressions are not computed until their values are actually needed. So the expression can be there all the time until it is needed, the value is needed, it will not be evaluated. So think of it like a smart waiter who doesn't start cooking your meal until you are actually ready to eat it. So this is in complete contrast with easier evaluation. Let's see here side by side easier evaluation and lazy evaluation. So easier evaluation, compute now. Lazy, compute when needed. Easier, evaluates expressions immediately. Lazy, delays a computation until required. So all values computed upfront in easier. In lazy, only computes what's actually used. In easier, may waste computation on unused results. And lazy can handle infinite data structures because it is not computing them uh, until needed. In easier, predictable memory usage. So of course you can see lazy is memory efficient for large data sets. Here is a visual flow. Easier, so define the expression, compute immediately, store result, use when needed. But result is already stored even before needed or used. For lazy, define expression, store computation recipe, wait for access, computer return. When somebody accesses, somebody actually want to know the result, then you compute and return. So here's the code example, basic lazy versus easier in the JavaScript. So expensive computation x, console.log, computing x, return x time x, so x cube, so constant easier results, 1, 2, 3, 4, 5 dot map, expensive computation, so log all computed. So as you can see, here is actually a call, you can say console.log using fast result dot easier results 0. In the output you can see that computing 1, computing 2, computing 3, 4, 5 all has been computed, and then using fast result 1 cube is 1, of course. So actually we do not need to find 2 cube, 3 cube or 4 cube or 5 cube, all of them. Only needed to know 1 cube. That's what has been asked, but we already have computed all of them. So this is easier evaluation. And in the lazy, so simulation class, lazy array, constructor, values, transformer, this is value, okay. And you can see here, lazy array, 1, 2, 3, 4, 5. Lazy array created using fast result. So output, so it doesn't even create the array until you have called this lazy results dot get 0, and only then it computes the index 0 and then find the first result. So easier evaluation, as we can already have seen, we have already saw that. Lazy example, no computation yet, setup done in 0.1 millisecond, computing 1 square only when needed. So that's it. So for example, in a real world example, so here we have Fibonacci for lazy, 0, 1 while true, yield AA. So we will later see that all the generator types Python functions, constructs, they do this lazy evaluation. All those functional programming constructs in Python, they do this. So finally, when actually called this first and fibs print, then this evaluation is actually happening. Uh, for example, Haskell is in this construct is naturally lazy, Haskell programming language. So it will not evaluate anything until actually needed. So only when it, this call for result is executed, then the results results are computed. Then we can see in logical operators, short circuit evaluation often use this lazy evaluation in JavaScript, for example. Expensive check, performing expensive check, method random greater than 0.5. Uh, if false and expensive check log, this should not print. So output nothing, expensive check never called. If true, so for example, if the construct is like true or expensive check, in that case, since the first expression is already true inside if, so expensive check will not be performed. So this will print. Expensive check will not be called, as you can see here. So advantages we have already seen: memory efficient, lazy evaluation, only compute what's needed, enables this, and this is precisely why it enables infinite data structures, faster startup times, avoids unnecessary computations, supports elegant recursive definitions, better performance for sparse data access, and disadvantages: unpredictable performance characteristics, debugging can be more complex, memory leaks from retained computations, space leaks in some scenarios, side effects can be confusing sometimes, not suitable for all problems domains. That goes for every type of evaluation, every type of strategies, right? Not suitable for all problem domains. There is nothing suitable for every problem domain. So languages and lazy evaluation, different language approaches. We already seen Python, selective lazy, generator iterators, and some built-ins are lazy, range, map, filter generators, and these are all also mostly used in functional programming construct for Python. And Haskell by definition functional programming language, and it is lazy by default. All expressions are lazy unless forced. Sequence, DeepSeek for forcing evaluation. In Java, we have this streams API, lazy operations on collections, stream.map.filter.collect. In JavaScript, we have seen short circuit and operators. So this is all we have for lazy evaluation. Peace.